Hey, beautiful people. Here we go with your video messages, the start of chapter 6. Hope everybody was successful with chapter 5 last week, and some of you might be still handing it in this week. But March 23rd, Monday. Here we go. Please go to page 385. Hope everybody had a good weekend. 385, 6-1 operations of functions. Here we go. The top of the page, we see arithmetic operations. When we're dealing with functions, we're going to do the same thing. We're going to look at addition, subtraction, multiplication, division. We're going to look to combine like terms. And we're going to combine it down and simplify it down as much as we can. So in today's lesson, we're going to basically just be looking at adding, subtracting, multiplying, and dividing. So when we look at addition in the middle of the page, okay, we're talking about functions. Okay, we're talking about potentially an f function, which would include some type of a polynomial, 3x squared plus 8x minus 4. Okay? So, as we look at that one function, now we're looking at, this is a composition, so it's more than one function. So we might also have a g function, which might be negative 3x plus 5. So when we look at these two functions, okay, we can do a number of things with them. We can add them, we can subtract them, we can multiply them and divide them in terms of how we combine them, okay? So if we're adding these functions, all we're basically doing is starting with the first function, 3x squared plus 8x minus 4. And we want to make sure we put them in parentheses to start with when we're adding and subtracting, mostly when we're subtracting, because we have to apply the negative to both terms inside the parentheses. So this one's just basically plus negative 3x plus 5. When we have this positive here, plus, doesn't affect these two at all. Okay? So we're basically just adding the functions, adding the like terms together. So we have, this is our only term for 3x squared. And when I'm combining functions, I normally try to either underline them, circle them, so I know that I've taken care of that term within the function. Here we have an 8x. Adding a negative is the same as subtracting, so we have 8x minus 3x, which would be 5x. Then we also have negative 4 plus 5 plus 1. That's all there is to it in terms of adding functions. You're just combining like terms. There's nothing else you really need to do. You're just got to make sure you identify positives and negatives and combine those coefficients accordingly. Okay? So that's the first thing is addition. Let's look at subtraction. Okay? If we're going to subtract, let's say if we have f of x function and we're going to subtract the g of x function, okay? We are going to look at, it's like saying this, f minus g of x, okay? F minus g of x, okay? So what we're going to do is we're going to start with my f function, 3x squared plus 8x minus 4. Then we subtract the whole function. Okay? When we subtract this, we have to apply our negative to both terms. Okay? Applying the negative to both terms. So we start here. Okay? Actually, we're not going to do that. We're going to just combine them while we do this. So we have negative of a negative is basically positive 3x. So we have 3x squared plus 8x minus 4. We also are going to subtract the negative 5. So a negative times a positive is a negative. Okay? Now we combine like terms. This is my only term with 3x squared. 8x plus 3x plus 11x. Two negatives, 4 and 5 make negative 9. Okay? Make negative 9. So we have combining both terms. Okay? We've worked on addition, subtraction. Let's just look at the flip side of this, where if we subtracted the other way. If we said, hey, we're going to start with the g function, okay, g of x, and we're going to subtract f of x. All we do is we flip it, negative 3x plus 5. Then we're going to subtract this whole term. So we're going to subtract the whole term, the whole f function. 3x squared plus 8x minus 4. Okay? Negative 3x plus 5. This negative applies to each term. Okay? To each term. We always want to put our answer in descending order, in standard form, which is in descending order. 3x squared. Now we have a negative 3x and a negative 8x, negative 11x. Combining my constant terms of 9. So it depends on the order that we're going to subtract. Okay, it's going to base it on the order that it subtracts. Now, so we've taken care of addition, subtraction. Now we're going to look at multiplication and division. Okay, multiplication. When we have polynomials and we're multiplying, we have to FOIL. Okay, we have to FOIL. So if we have f of f times g of x, so we're going to multiply the two together. Okay, we have 3x squared plus 8x minus 4 times negative 3x plus 5. When we FOIL each term in the first trinomial, we're going to multiply with the binomial on the back side, right? Not negative 9x cubed, right? X squared times x is x cubed. 3x squared times 5, 15x squared. 8x times negative 3x, negative 24x squared. 8x times 5 plus 40x. Negative 4 times negative 3x plus 12x. Negative 4 times negative 5 times positive 5 is negative 20. Make sure I did that right. Now we combine like terms. Only one x cubed. We have x squared. 15 minus 24, negative 9x squareds. 40x plus 12x plus 52x minus 20. Okay? So we're multiplying, we're FOILing those terms. Okay? When we look at example 1 in the book on page 385, okay, that example 1 is talking about just adding and subtracting. Adding and subtracting. We turn the page to example 2. Okay, to example 2, middle of page 386. Okay, and we multiply means we have to FOIL. Same type of example in example 2a is what I did on the board here. Now we're going to divide. Okay, now we're going to divide. Okay, so when we divide, we're going to say we want the f function over the g function of x. Okay? So we're going to divide those terms. Now, when we divide, all we do is put my f function on top. My g function on the bottom. It's all we have to do when we divide the terms. Okay, when we divide the functions. Now, when we have a variable in the denominator, we can never have a value of 0 in the denominator. So what do? We say we put whatever's in the denominator, negative 3x plus 5, cannot equal 0. Because when we have a 0 on the denominator, it is an undefined term. So we also always have to have a restriction. So there's going to be a restriction on the domain. When we add two together and there's no variable on the bottom, we could plug in all real numbers. When we subtract, same thing. We can plug in all real numbers. But when we have a variable on the denominator here, there's going to be a restriction. We can't have it equal to 0. So then we just solve for x. X cannot equal 5/3. Okay? So here's my answer for division of my functions. We also have and x cannot equal 5/3. Meaning we can plug in any number in this composition function, in this division of functions. We can plug in any number in here except 5/3. Because if we plug in 5/3 over here, okay, this will become 0. And we can't do that. Okay? So, review. Adding, subtracting, multiplying, and dividing functions have to have, the domain can be all real numbers when we multiply, divide, multiply, add, or subtract. If we divide and we have a variable in the denominator, we have to find the restriction. Okay, we have to find the restriction, and that information is going to be in example 2 for you. Example 2. All right, so there's your first lesson. Get working on it this afternoon. Not very many problems. Get working on it today and tomorrow. And on Wednesday, we'll be going over the second half of lesson 6.1, operations of functions. Peace out.